Hi, and welcome back to API Can Code's third unit, Data Science Practices. Today we're looking at tests and estimates in one variable. We start off with a warm-up, looking at how much teens say they use different social media platforms, including YouTube, TikTok, and Snapchat. As with previous exercises, we're hoping that this is somewhat interesting to our students and a little bit engaging to get them thinking about the ways data can be presented in visuals on a topic that they actually somewhat care about. So to recap lesson 3.4, we learned about using CodeApp to create data visualizations in two variables, often showing relationships. We usually use scatterplots to visualize relationships between quantitative variables, and usually use two-way dot plots and segmented bar graphs to visualize qualitative relationships. So today we're going to look at data taken from Zillow Research's housing data page. There's a link to that page here in case you want to look at it more. And some background. Zillow is a website that can be used to search for properties for sale and find buying and selling resources. And the data set that we have gives a Zillow Home Value Index, which is supposed to reflect the typical value for homes in the middle range for a certain city. So we're going to start with some exploratory practice. We want students first to open the Zillow dataset, see what kinds of variables there are, and what states are represented here. In this initial data set, it is Maryland and Virginia. So we want students to create some graphs that they think are interesting and interpret what they show. And then we walk them through some more specifics. If students haven't done this yet, create a graph with average value home on the x-axis and state on the y-axis. This will create a dot plot for Maryland and another for Virginia. Students should explore this plot, see what they notice, see what they wonder, and consider are there any outliers? And students can actually test this by going to the ruler icon, selecting box plot, then going back to the ruler icon and selecting show outliers. This will actually have CodeApp go through and label any outlier points on that graph according to its internal metrics. Students could talk about what they think CodeApp is using to determine an outlier. It may be 2 or 3 standard deviations above the mean. It also may be 1.5 IQRs outside quartile 1 or quartile 3. We don't really need a definitive answer here, just want students to start thinking about how outliers work and where those cutoffs might fall. We're going to go back to the ruler icon and add a mean to the comparative dot plot. So this should show a mean for Maryland and a mean for Virginia. Then we're going to go back to the ruler icon, click on measures of spread, and select standard deviation. We ask students, how do you use these metrics to decide whether Maryland or Virginia is more affordable? One answer might be just that one mean is higher than the other, and that means houses there are more expensive. Another, maybe more comprehensive answer might be looking at the range covered by the standard deviation in each case and seeing how much those overlap, because that'll tell you something about how much the average houses in those two states actually differ from each other, or maybe don't differ all that much. We also ask students to think about what other information they'd want when thinking about which state is more affordable and how they'd get their hands on that data. So now we're going to focus in on Washington, D.C., sitting right between Maryland and Virginia. Students are going to use a program that is linked in this slide. This is an EduBlocks program like the ones that they've used before. And they're going to collect a sample of available properties in D.C. They can do this by going to that Rapid API page that is linked here. That's going to draw in data from Zillow. Students should subscribe to test, choose the free option, and then go back to endpoints. Make sure that the search or /search endpoint is selected and find their API key in the code snippets. Students have done this a couple times now where they grab links and URLs and things like that from an API page and set up their program. So hopefully this is mostly review, but you might want to encourage them to look back at their previous work in case they're struggling to do this again. It has been a couple lessons. So that program should generate for students comma separated values output, CSV output. That should allow them to copy the output, open CodeApp, which we've got a link to here, and create a new document. From there, students should be able to click Tables and select New from Clipboard. This will paste in the data that they just copied from their program. And at this point, they can take a look at it in CodeApp's interface, which, as we've seen before, is tabular. They can make graphs to explore the data, so they can really dig into this data a little bit at this point. We want to start thinking about confidence intervals and what they are. That's a key part of today's lesson. So we asked the question, how would you find the average home price in the entire United States? This is a good discussion question for the whole class. Students might note that a census would be really awesome, right? Just take literally every single house, add the values up, divide by the number of houses. But of course, this would be incredibly expensive and incredibly time consuming. You'd need a ton of information to come in pretty quickly since house prices are always changing. And you'd have to be able to get the phone numbers, for example, of every homeowner in the United States, which seems a little bit unrealistic in a short span of time. So what a confidence interval would do for us is take the mean of a sample and build that out to get a range where we think the mean of the entire, could be the country, could be the state, could be the city, falls. So the other way we might use confidence intervals is comparing two city housing prices. Here, we might make a confidence interval using a sample from each city and compare those two intervals. If the intervals overlap, like I think we saw with the Maryland-Virginia case, it means the city mean housing prices could be the same, or at least similar enough with enough variance to individual house prices that we might not notice all that much of a difference between those two places. On the other hand, if the two intervals don't overlap, it means the city mean housing prices are probably actually kind of different. Like one state might be cheaper than the other, one city might be cheaper than the other. So we're going to use this confidence interval idea in two different ways. First, students are going to, using this DC dataset, they're going to drag price on the x-axis of a new graph to create a dot plot. Then they'll go into the ruler icon, click mean, then click back on the ruler icon, go to measures of spread, and add 2 standard errors. And what this is going to generate for them is a confidence interval for the mean housing price in DC. So there'll be the mean in the center, that's the mean of the sample they have, and then it should give error bars on either side to show where that mean potentially could fall according to this interval. Students should add the 2 standard errors shown from the graph to the mean and subtract that same amount from the mean. This will give a lower and upper limit to this confidence interval, which again is a range of values where that true mean could probably fall. Okay, I want to talk a little bit about standard deviation versus standard error, just as this has been confusing before. Standard deviation is the average difference between each observation in the data set and the mean of that data set. On the other hand, standard error is at the sample level. So this is talking about the average difference between the mean of each sample and the mean of the population as a whole. So standard error is more sort of the space we're operating in when we think about how different our sample could be from the true mean. This is also a good time to talk about standard deviation as a measure of spread. Populations or samples with a higher standard deviation are going to be more spread out. Your average value might be further from the mean. So you see over in this distributions to the right, the yellow distribution has a pretty high standard deviation. This one's 20. Populations or samples with a smaller standard deviation, on the other hand, will be less spread out. So this is like the blue curve to the right. So a little more on confidence intervals here, now that we've reviewed standard deviation and standard error. Confidence intervals are going to be constructed using the mean of a sample and the standard error, which again is the average deviation of that sample from a true population mean. And what this will help us do is get a range of values where we think the population mean could possibly fall. So to help students imagine this, imagine they're trying to predict the average streams per day for your favorite artist. Would we get a good estimate if we checked 5 days worth of streams, averaged them, and said, bam, there's our number? Or should we include something that accounts for the variance across each day of that artist's streams? And that might sort of let us build a wider net of guesses that might include sort of some values below that 5-day mean and some values above that 5-day mean. Confidence intervals have a lower limit and an upper limit. And in 95% of intervals that get constructed from samples like the one that we have in front of us, will include the true DC mean housing costs in the example that we're thinking about. Importantly, the corollary to this is that 5% of the intervals that we construct will not include that true mean housing cost anywhere in the interval, and we have no way of knowing which ones are right and which ones are wrong. To test students' understanding of this concept, ask them whether the graphic on the right shows a 95% confidence interval. If they kind of understand this, they'll notice that there are too many misses. In fact, half the intervals do not include the true mean, and only 50% of them do. So this is actually probably a 50% confidence interval shown to the right. Okay, so we're now going to move up to our two-sample confidence interval problem. And so what we want students to do is go back into their program, look for the line that says query string equals location Washington, D.C., and replace this with another location that they're interested in. So if I wanted to look at San Francisco, I would change that line to read query string location San Francisco, CA. Students will need the city, comma, the state abbreviation, so you might need to support them a little bit on that. But the goal is that they're looking at some location that they're interested in. They should run that program again. And what they'll do is, again, copy the output, go back to CodeApp, go through tables and new from clipboard, and create a new table with that new location's data. So again, we want students to create a graph, drag price from the new data onto the x-axis. So this should generate a dot plot for price for the new city, not DC. They should still have the DC data set as well. And then they should run their basic calculations. What's the mean? What's the standard deviation? So again, using the ruler icon, students are going to display the two standard error confidence interval. They should show the mean. They should go to measures of spread. They should show two standard errors. So again, they should calculate the lower and upper limit for this new city's confidence interval and compare this to the interval they got for DC. Here are some worksheet questions. What do you think it means if the confidence intervals overlap? What do you think it means if they don't overlap? Overlapping is generally a sign that two populations aren't that different. Not overlapping is generally a sign that those two populations are different. Our exit ticket today uses a Ravens and Commanders game. So students should open this CodeApp file. It'll show them the data behind these graphs and the graphs shown on this slide. And we ask them, how could you use the information provided to decide who they think would win if the Ravens and Commanders played each other again this season? This is a bit of a 50-50 shot. The answer is not really as important as the reasoning. These confidence intervals overlap by just the tiniest of amounts. So you could have a student argue that because the confidence intervals overlap at all, we can't really tell that the teams are scoring sort of different points per game. On the other hand, a student might say, yeah, but the Ravens scores really tend to be higher. There's only the slightest bit of overlap, so I think that the Ravens is different and higher than the Commanders' average score in the population. As always, thank you for watching this lesson walkthrough, and thank you for teaching the API CAN code curriculum.